like about the program when you started? What attracted you to it?
How the students answer the questions and how everything went on.
Okay, and you?
The authenticity of the program.
Okay, and it's meeting your expectation, being
Yes,
contestants yourself?
Yes, madam.
Okay, that's good. I know you put in your best, so I won't ask you any other things. All the best to you, gentlemen.
Thank you, madam.
Good. Osei Tutu Senior High School is represented by Osei Tutu Senior High School is represented by
Opoku Ware final year.
How are you, gentlemen? You are well. That's good. We are talking about the 30th anniversary of the National Science and Math Quiz. When did you start watching the program?
When I was in Form 1 JHS.
Okay, good. And you?
When I was in JHS 3.
I see. What did you like about it?
The speed round.
The speed?
Yeah. The morale the supporters were giving to the contestants in school.
I see. Okay. And in what way has this benefited you as contestants also? The program?
Okay, so it has helped me personally to develop certain techniques that I've learned from past contestants on how they control the pressure and solve the questions.
School. St. John's School is represented by
Nana finished sound of final year. Daniel Tuakwatechi, final year.
You're most welcome, gentlemen.
Thank you.
How are you?
We are fine.
Good. We are chatting about the 30th anniversary of the National Science and Math Quiz. When did you start watching it?
I started watching when I was in JHS.
All right. And you?
Also in JHS.
Okay. What did you like about it?
From the competition to the jubilation, everything about the whole program, I liked it.
Okay. And you?
What I know is it's a program of mixed feelings, and I especially like it about the excitement and the jubilations.
All right, I'm happy to hear that. Has it benefited you personally?
Yes, please.
Yes. Just mention something, how it's been of benefit to you.
Okay, so it has groomed me a lot from the time I started SHS, and I think it has prepared me for the tertiary, the life ahead.
All right.
Apart from the academic importance, it's also helped in how to conduct yourself when you are found in public, and I like that one too.
Okay. Thank you for sharing all of that.
You're welcome.
Best wishes to you. Correctly, 3 points. If the question is incorrectly answered, it becomes available to the 2 remaining schools. A school may ring and attempt an answer. If right, a bonus point. If not, there's a penalty, 1 point. For questions that require calculations, you have 30 seconds to present your answer. If there are no calculations involved, you have 10 seconds to do so. Gentlemen, all of the questions are to be attempted once only. Best wishes to all 3 schools. I will start with you, St. John's School, okay? But before then, this first set of questions will require about 30 seconds of your time, and I have a short preamble to all schools. Preamble. Solve the exponential equation for x. That's the preamble. I hope you got that. All right. So St. John's School, the expression 3x squared minus 3x minus 5, this expression raised to the power of the expression x minus 3 is equal to 1. Yes, Daniel.
X is equal to 3, or x is equal to 2, or x is equal to negative 1.
You are right. Osei Tutu with the same preamble. The expression x squared plus x minus 11 raised to the power of the expression x plus 2 is equal to 1. Faisal?
X is equal to negative 2, or x is equal to negative 4, or x is equal to 3.
You are right. Opoku Ware School with the same preamble. The expression x squared minus 2x minus 14. This expression raised to the power of the expression x plus 5 is equal to 1. Steven?
X is equal to negative 3, or x is equal to 5, or x is equal to negative 5.
Yes. Next set, 30 seconds again. St. John's School. Find the focal length of a spherical biconvex lens in air whose refractive index is 1.60 and whose surfaces have radii each of magnitude 0.30 meter. Daniel?
Negative.
Go ahead.
Negative 9 centimeters.
That's incorrect. For a bonus. Yes. Go ahead.
By 10 exponents, negative 1 meters.
Again.
2.5 by 10 exponents, negative 1 meters.
Yes. Major question. I believe you were warned that if I have not given a ruling on an answer, you don't ring. Your major question. the focal length of a spherical meniscus lens in air whose refractive index is 1.50 and whose convex surface has radius of magnitude 0.30 meter and whose concave surface has radius of magnitude 0.40 meter. Faisal?
2.9 meters.
That's incorrect for a bonus. The right answer is 2.4 meters. Opoku Ware School. Find the focal length of a spherical biconcave lens in air whose refractive index is 1.60 and whose surfaces have radii of magnitude 0.30 meter and 0.70 meter. Yes, Stephen.
Negative 0.35 meters.
Yes. This next set will only require 10 seconds of your time. And I have a short preamble to all schools. Give the name of the element with the given symbol. So I'll give you a symbol. Please give the name of the element. That's the preamble. All right, so St. John's School, capital R, small g. Daniel?
Royentangium.
Again?
Royentangium.
No. Yes, Stephen.
Point genium.
Yes. Osei Tutu with the same preamble. Capital T, small s. Yes, Faisal?
Tennis sign. Tennis sign.
Yes. Opoku Ware School with the same preamble. Capital T, small m. Yes, Stephen?
Thulium.
Yes. Next set, 10 seconds. St. John's School. Name the first product of the C4 pathway. Yes, Nana.
Oxalic acid.
Pardon?
Oxalic acid.
No, I'm not accepting it for a bonus. It's oxaloacetic acid. All right. Osei Tutu, name the final product of the C4 pathway. Roger?
Okay, we have the oxalate.
That's incorrect for a bonus. The right answer is malic acid. All right. Opoku Ware School. Where does the Calvin cycle occur in C4 plants? Yes, Stephen.
In the bundle sheet.
2 out of 3. In the stroma of the bundle sheet. Next set, 30 seconds with a preamble to all schools. Preamble. Find the completely factorized cubic polynomial f of x such that, okay, so my keywords are completely factorized. Okay, so find the completely factorized cubic polynomial f of x such that. All right, St. John's School, f of 1 is equal to f of negative 2 is equal to f of 3, and all of this is equal to 0. And f of negative 1 is equal to 16. Yes, Nana.
F of x is equal to 2, multiplying the expression x minus 1, multiplying another expression x plus 2, multiplying another expression x minus 3.
You are right. Osei Tutu with the same preamble. F of 2 is equal to f of negative 1. And this is equal to f of 4, and all of this is equal to 0, and f of 3 is equal to negative 12. Yes, Roger.
Okay, we have the f of x to be equal to x minus 2 multiplying x plus 1 multiplying x minus 4. No.
That's
All
incorrect.
this expression
Go ahead. All right. Your major question with the same preamble. Can you check the question with the same preamble? F of 3 is equal to f of 5 is equal to f of negative 4. And all of this is equal to 0. And f of 1 is equal to 80. Yes, Dante.
f of x is equal to 2 multiplying x minus 3 multiplying x minus 5 multiplying x plus 4.
You are right. Next set, 30 seconds. And I have a preamble to all schools. Please listen carefully. A simple machine comprises a frictionless pulley over which a light, inextensible string runs. The ends of the string supporting masses M1 and M2. Find the magnitude of the acceleration of each mass for the given values of M1 and M2. Did you get your preamble? Okay, one more time. A simple machine comprises a frictionless pulley over which a light inextensible string runs. The ends of the string supporting masses M1 and M2. Find the magnitude of the acceleration of each mass for the given values of M1 and M2. St. John's School, M1 is equal to 0.50 kilogram and M2 is equal to 0.30 kilogram. Yes, Nana.
The acceleration for the acceleration for M1 is equal to 0.38 meters per second square, and the acceleration for M2 is 0.63 meters per second square.
That's incorrect for a bonus. All right, I'm holding on to the answer. I'll come back to you. With the same preamble, Osei Tutu, M1 is equal to 0.40 kilogram and M2 is equal to 0.50 kilogram. Yes, Roger.
Okay, we have the acceleration to be 1.1 meters per second squared.
Yes. With the same preamble, Opoku Ware School, M1 is equal to 0.20 kilogram and M2 is equal to 0.30 kilogram. Seven.
2.0 meter per second squared.
You are right. St. John's School, your answer was 2.5 meter per second squared. Next set, you need 30 seconds. But it's one of those questions where I move around for right answers. So when I get to your school, provide me with a right answer, then I'll move on. No bonus available this time. So the question is a simple one question that I'm moving around. Okay, so this is the question. Give the systematic name of one substituted non-cyclic structural isomer of methyl cyclobutane. That's the question. So St. John's School, first choice. Nana.
You have 2 methyl, 1 butene.
Again?
2 meter 1 button.
You are right. Osei Tutu. Faisal?
3 meter 1 button.
You're right. Opoku Ware. Yes, Damte?
2 meter 2 button.
You are right. Next set, 10 seconds. What name is given to two related but geographically isolated species? Yes, Nana?
Allopatric species.
Yes. What name is given to the formation of two species from one ancestral species? Faisal?
Sympatric speciation. Sympatric speciation.
No. For a bonus. Yes. Daniel?
Divergent speciation.
Species.
No, I can't accept for a bonus. It's divergent evolution. All right. Opoku Ware School, name the type of fossil that includes footprints, trails, tracks, and tunnels of various organisms made in mud and rapidly filled in with sand and covered by sediment. Yes, Stephen?
Anthropogenic fossil. Anthropogenic fossil.
That's incorrect for a bonus. The right answer is impressions. Impressions. Next set, 30 seconds with a preamble to all schools. Preamble. Find the set of values of k such that the quadratic equation, shall I repeat it? Find the set of values of k such that the quadratic equation, all right, so St. John's School, x squared plus the expression k minus 2 multiplying x plus k minus 3 is equal to 0 has distinct real roots. Is that hand up, Daniel? Go ahead.
The set of K such that K is a member 4.
Yes. All right, with the same preamble, Osei Tutu, x squared plus kx plus the expression expression k plus 3 is equal to 0 has no real roots. Yes, Faisal?
K is such that -2.
Opoku Ware School with the same preamble. X squared minus 2kx plus the expression 2 minus k is equal to 0 has real roots. Okay. Osei Tutu, have you figured out why you have? Thank you. All right. Next set, 30 seconds with a preamble to all schools. Preamble. Particle displacement at time t and position x in a standing wave is given by y of xt is equal to a multiplying cosine of the expression 2 pi x over lambda multiplying sine omega t, where a is equal to 1 meter, lambda is equal to 4 meter, and omega is equal to radians per second. Find the wave amplitude at the given position. Again, all right. Particle displacement at time t and position x in a standing wave is given by y, which is a function of x and t, and it's equal to a multiplying cosine of the expression 2 pi x over lambda multiplying sine of omega t, where a is equal to 1 meter, lambda is 4 meters, and omega is equal to 5 pi radians per second. And you have to find the wave amplitude at the given position. All right, so now St. John's School, x is equal to 2 meters. Daniel?
0 meters.
That's incorrect. For a bonus. All right, I'm holding on to your answer for a moment. All right, Osei over 2 meters. Is that hand up? Faisal, go ahead.
0.
That's incorrect. For a bonus. I'll hold on to that. Opoku Ware School with the same preamble. X is equal to 4 over 3 meters. Seven.
0.5 meters.
Again?
0.5 meters.
You're right. St. John's School. St. John's School, yours was 1 meter. And then Osei Tutu, yours was √2/2 meter. Next set, 30 seconds. St. John's School. Determine the percentage composition by mass of oxygen in butane 1,2-diol. Nana?
How many is it? We have 35%.
Pardon?
35%.
That's incorrect. Yes. 7.
36%.
Yes. It's Osei Tutu. Determine the percentage composition by mass of carbon in 3-methyl-butanol. For a bonus, okay. Okay, I'm happy to give the answer. It's 69.7% or 70%. I would have accepted either. All right, Opoku Ware School. Determine the percentage composition by mass of carbon in 1-methyl-cyclopentanol. Stephen, is that hand up? Okay, go ahead.
72%.
Yes, 72%. Last set of questions for the round. Ten seconds. And I have a short preamble to all schools. Preamble. State the location of the given valves in the heart of humans. I hope you got it. State the location of the given valve in the heart of humans. St. John's School, aortic valve. Yes, Daniel?
The aortic valve is the valve that separates the aorta from the left atrium of the human heart.
Yes, go ahead.
The aortic valve is situated between the aorta and the left ventricle of the heart.
Yes. The mitral valve. Roger?
It's in the left atrium. Okay, so the mitral valve separate it's located between the left ventricle and the left atrium.
Yes. Opoku Ware School, last one. Pulmonary valve. Yes, Dante?
It is located between the pulmonary artery and the right ventricle.
Yes. And that's the end of the first round. If it's a second attempt, 2 points. If it's a third attempt, 1 point. But please be careful, because if you attempt to answer a question and you are unsuccessful, meaning you are not able to provide the correct answer, or you do not provide your answer in 3 seconds, you lose a precious point. How do you know that you've exceeded your 3 seconds? You will hear that bell. The moment you hear that bell, whatever it is you are saying or not saying, that's your answer. And so then, obviously, it fetches you a negative point, right? For questions which require calculations, you have 30 seconds to provide an answer. If there are no calculations, you have the usual 10 seconds. Best wishes, everyone. First set of questions will require 30 seconds of your time, each of them. All right, first one. At a given temperature, butane effuses through a pinhole at 1.5 times the rate of an unknown gas. Determine the molar mass. Yes, Dante.
7 grams per mole.
That's incorrect. I continue. Determine the molar mass of the unknown gas. Yes, Faisal.
16.5 grams per mole.
That's incorrect. The right answer is 130.5 grams per mole. Next one. Determine the sum of the whole number coefficients of reactants and products in the balanced equation for the complete combustion of hexanal. Yes, Dante.
43.
Yes. If you don't raise your hand, I'm at liberty to call either one of you. I hope you know that. All right. Determine the mass of nitrogen present in 2.7 grams of ethanamine.
$0.84 grams.
Yes. Next set, 10 seconds. 10 seconds. Mention the structure in which transplantation occurs if a person is undergoing artificial pacemaker transplant. Yes, Stephen.
The heart. The heart.
No. Okay, of course, it's the heart, but it's a specific part of the heart. It's the sinoatrial node, the SA node. That's a structure. You were asked for structure, not body part. Okay, next one. What is used to express the degree of acidity or alkalinity of a food or a given solution? Yes, Roger.
pH scale. The pH scale.
Yes, it's you. Next one. In which part of the human eye does most of the refraction? Okay. Yes, Daniel.
The cornea.
I'm not accepting it, so I continue. Yes, Faisal.
The islands. Islands.
No. Okay, I continue for your benefit, Opoku Ware. I continue for your benefit. Does most of the refraction of light rays entering the eye occur? And you have to be specific. It occurs on the outer surface of the cornea. So that's when most refraction occurs. That's when it's entering from the air to the outer surface of the cornea. Yes. All right, next set, 30 seconds. A particle is moving in a straight line with uniform acceleration. It covers a distance of 100 meters as the speed increases from 10 meters per second to 30 meters per second. Yes, Roger.
4 meters per second squared.
Yes. Set A has 3 elements and set B has 2 elements. Find the number of possible ways of mapping from A to B. 7.
6 ways. 6 ways.
That's incorrect. Daniel.
Ways. 10 ways.
No. The right answer is 8. Next one. Find the coordinates of the stationary point of the curve y is equal to the expression x squared plus 1. Okay, go ahead. Roger.
0.1.
Yes. I wonder how you did your guesswork. I'm really curious. Do you want to share? Do you want to share? Osei Tutu. Okay, so the curve was y is equal to the expression x squared plus 1. This expression raised to the power 6. Yes. And so that was some serious guesswork right there. Next set, 30 seconds. And this is the last set of the round. First one. If in a Frank Hertz tube, the first current dip is observed at 10.2 volts, what wavelength can one expect to observe in the emission spectrum of the atomic vapor in the tube? Yes, Stephen. Answer.
1.6 times 10 to an exponent of -7 meters.
Repeat, I didn't hear.
1.26 times.
That's incorrect. Who rang next? Yes, go ahead, Roger.
1.20 by 10 to the power.
That's incorrect. Did you ring? Go ahead.
1.24 by 10 to the power -7 meters.
That's incorrect. The right answer is 122 nanometers or 1.22 times 10 raised to the power -7 meters. Next one. Find the voltage at t equals 1 second across a 2/pi Henry inductor if the current through it is given by 5 ampere multiplying sine of the expression 6 pi t per second. The right answer is 60 volts. Last one for the round. Find the length of a uniform cantilever beam that oscillates with a period of 0.20 seconds, given that a 2.0 meter beam of the same geometry oscillates with a period of 0.40 seconds, and that period is proportional to square root of beam length. Yes. Daniel.
8.0 meters.
That's incorrect. The right answer is 0.50 meter. And that's the end of the second round. At the end of the second round, St. John's School has 11 points. Osei Tutu Senior High School has 24 points. Opoku Ware School has 35 points. Before we begin the next round, we have a couple of substitutions. Osei Tutu, Roger, it's been a pleasure having you. All the best. And we have Peter coming in for Roger. Peter. You're welcome, Peter. Opoku Ware School. Damte, it's been a pleasure. All the best to you. Coming on is Forsen. You're welcome, Forsen. Round 3. This is the round with the problem of the day. At stake in the round is the Prudential Life Insurance NSMQ Star. The Star is an award that is given to a school that earns a perfect score of 10 points in the problem of the day. At this stage, the Star is worth 2,800 Ghana cedis. I know you'll be working hard towards that, right? Good. All right, so the problem of the day is a problem that will engage you for a little longer than we have seen. So from the time I ask you to begin, you will have 4 minutes to present your answers on the board, right? Good. Please stand. Drop your pens. And now you may pick up the problem of the day so we can read together. We are only reading. Problem of the day. An electron beam is generated by illuminating a photocathode with monochromatic light of wavelength lambda. A. Explain why the de Broglie wavelength of the photoelectrons does not equal the wavelength of the incident light. B. Explain why the linear momentum of each photoelectron does not equal the linear momentum of an incident photon, and state, if any, which conservation law is violated. C. Give an expression for the maximum kinetic energy of an electron in the beam after acceleration through a potential difference V. Define any new symbols you use. And D. Use your expression in C to derive an expression for the shortest wavelength X-rays that may be generated using the electron beam that has been accelerated through a potential difference V, assuming V does not exceed, say, 5 kilovolts, and the photon wavelength is not too short. Contestants, this is your problem of the day. You may now begin. The contestants have presented their answers. Before I award the points, let's look at the suggested solution from the consultants. This is a problem from physics. So we are told that an electron beam is generated by illuminating a photocathode with monochromatic light of wavelength lambda. Contestants were to do 4 things. Let me take them one after the other. The first one was to explain why the de Broglie wavelength of the photoelectrons does not equal the wavelength of the incident light. Okay, actually there's a major hint in this problem which you have to be aware of. The 2 wavelengths, you will notice very shortly, so the 2 wavelengths are not the same because the momentum of a photoelectron does not equal the momentum of the photon that ejects it. That's the reason, okay? So from this, you see where the hint is coming in. The second question is actually where the hint came in, momentum. Okay, so, and by the way, this was worth 2 points. If you were able to say this, 2 points. Second one, they were to explain why the linear momentum of each photoelectron does not equal the linear momentum of an incident photon, and state, if any, which conservation law is violated. And this is the answer. The 2 linear momenta are not equal because the electron is initially bound. So the interaction between the photon and the photocathode, in fact, involves not just the photon and electron, but also the atom to which the electron is bound, which recoils in the process. Okay, so the atom will recoil in the process. You have to know that there are implications to this. So this recoil accounts for the momentum difference between electron and photon. So momentum conservation is not violated. There is no violation here. If you are taking care of the whole system, no violation has occurred. So note that a free electron cannot absorb a photon and conserve both energy and momentum. A bound electron can do so because of the recoil that has been described. I hope this is clear. Are you people learning something from this? Great, that's what I like to hear. Okay, the third one. Contestants were to give an expression for the maximum kinetic energy of an electron in the beam after accelerating it through a potential difference V. And if any symbols are used, you define them. Okay, so let the work function of the photocathode be W. These are the things we normally do, right? So the kinetic energy of the most energetic photoelectron, this is K0, is equal to hc over lambda minus W, which is the work function, where h is Planck's constant, c is the speed of light in vacuum, and this presumes that hc over lambda is greater than W because to start with, since otherwise no photoelectron can be produced. Now that photoelectron is accelerated through a potential difference V, it gains additional kinetic energy, and this additional kinetic energy is EV, right? So its total energy is going to be given by the K0, which we've talked about, plus this extra energy EV, and we can rewrite this in terms of the wavelength. So this becomes hc over lambda plus EV, and then we subtract the work function from it. Okay, if you are able to get this far, you get 3 points. All right, so of course E is the magnitude of the fundamental charge. I hadn't defined that one yet. Okay, then finally contestants were to use the expression that we have right now to derive an expression for the shortest wavelength X-rays that may be generated using the electron beam that has been accelerated through a potential difference, assuming that the potential difference does not exceed 5 kilovolts and the photon wavelength is not too short. Okay, so if the potential difference does not exceed 5 kilovolts, and the photon wavelength is not too short, the motion of the photoelectron is relatively slow, and so we don't need to worry about relativistic matters, right? So now the momentum P can be given by square root of the expression 2mk. And so we know what the k is because that's what we got for the third part. So we substitute this and we'll get square root of 2m multiplying that expression which we had, which was hc over lambda plus ev minus the work function. All of the square root. And then the corresponding de Broglie wavelength, the de Broglie wavelength is given by this momentum which we have just obtained divided by Planck's constant. So we will have 1 over h multiplying square root of 2m and that expression which we obtained previously. If you get to this point, 3 more points. So 2 points for A, 2 points for B, 3 points for C, and 3 points for D. This is how the mark allocation went. Contestants, I tried really hard for you people. I tried, I was reading, I was searching. Some people even said that some laws had been violated. Very shocking and scandalous. To summarize, none of these contestants could see top. For that reason, I am awarding zeros all round. That's the end of the problem of the day and the end of round 3.
What are you going to do?
Statement, please consider it carefully and let me know whether the statement is true or false. If you're right, 2 points. If you're incorrect, you lose a precious point. You may choose not to respond, in which case that statement is available to the 2 remaining schools. A school may ring and attempt an answer. If right, 2 full points. If not, there's a penalty, 1 point. Most of the statements will require you to use only about 10 seconds of time, but should there be a statement that requires some calculation, you will be given up to 30 seconds. Best wishes. I'm starting with you again, St. John's School. Your statement. Nitrates can easily be reduced to nitrites. Yes, Daniel?
False.
No, it's a true statement. Osei Tutu. Iodides can easily be reduced to iodates. Peter?
False.
You're right. Opoku Ware. Sulfates can easily be reduced to sulfides. Yes, Forson?
True.
Yes, you're right. For the next set, I have a preamble. When I get to your school, I will give you a statement regarding the chemical classification of hormones. Okay? So, indicate whether what I give you is a legitimate classification of hormones, chemical classification of hormones, whether it's legitimate or not. If it is, you tell me true. If it's not, false. All right, so St. John's School, amino acid-based hormones. Yes, Daniel?
True.
Yes.
know, please.
Osei Tutu, glucose-containing hormones. Yes, Peter.
False.
Yes. Opoku Ware, protein-based hormones.
False.
Yes, Forson.
False.
No, it's a true statement. For the next set, I have a preamble to all schools. Preamble. Two particles, A and B, move with constant velocity. The velocity of particle A is 3I meter per second, and the velocity of particle B is 5I meter per second. Please, did you get the preamble? Again, two particles A and B move with constant velocity. The velocity of particle A is 3I meter per second, and the velocity of particle B is 5I meter per second. St. John's School, particle B is farther from the origin than particle A. Daniel?
True.
No, that's a false statement. Osei Tutu, the velocity of particle A relative to particle B is negative 2I meter per second. Yes, Peter?
True.
Yes. Opoku Ware. Particle A and particle B both move along the x-axis. Forson?
True.
No. For the next set, I have a preamble to all schools. Preamble, a short preamble. For a reflex angle theta, that's a preamble. For a reflex angle theta, St. John's School, sine of theta is less than 0. Daniel?
True.
Yes. Osei Tutu, cosine of theta is greater than 0. Peter?
False.
Yes. Opoku Ware. Tangent of theta is less than 0.
False.
Forson?
False.
Yes. St. John's School. 1 butene has a higher boiling point than 2 butene. Daniel?
False.
Yes. Two butene has a lower boiling point than 1 pentene. Peter?
True.
Yes. 2-butene has a lower boiling point than trans-2-pentene? Forsen.
False.
No. St. John's School. Epithelial cells rest on a cellular basement membrane, splitting it from underlying connective tissues. Daniel.
True.
No. Epithelial cells cover the external body surface and the internal surface of some organs. Peter.
False.
No. No blood vessels supply nutrients to epithelial cells. Forsen?
True.
Yes. The direction of the polarization of a polarized light wave is the direction of propagation of the wave. Daniel?
False.
Yes. The direction of polarization of a polarized light wave is the direction of the magnetic field of the wave. Peter?
False.
Yes. A light wave is said to be plane polarized in the x direction if the electric field of the wave is always parallel to the x-axis. Forsen?
False.
No. Last set of statements for the round. Last set. The function f of x is equal to x multiplied by cosine of x. It's an even function. Yes, Daniel?
False.
You're right. The function f of x is equal to x multiplied by sine of x. It's an even function. Peter?
True.
Yes. Last statement, last one. to x multiplied by tangent of x is an even function for negative pi over 2 less than x less than pi over 2. Forsen.
True.
Yes. And that's the end of the fourth round. Ware School has 39 points. Round 5. Contestants, let me remind you of the Goil Super Bonanza, which happens in this round. Goil will offer a prize of 2,000 Ghana cedis to any school that solves all 4 riddles. If you solve 3 of the 4 riddles, you get 1,600 Ghana cedis. If you solve 2 of the 4, you get 1,000 Ghana cedis. And if you solve 1, you get 500 Ghana cedis. Very generous. Goil, good energy. All right, so in this round, we are going to be solving riddles. I'm going to be reading out the clues. Your objective is to solve the riddle. For an opportunity to solve a riddle, you must ring for it. May I hear your bell, Opoku Ware School? Thank you. Yours, Osei Tutu. Thank you. And yours, St. John's School. Thank you. If you solve the riddle on the first clue, 5 points. On the second clue, 4 points. On the third or any clue thereafter, 3 points. There are 4 riddles. Best wishes, everyone. I am a small haploid cell. I was first reported in 1824 by Carus in gastropods, but my role was not clarified until the work of Bushley in 1875. I am formed at the same time as an egg cell during oogenesis, but generally, yes,
Polar body.
yes. Next one. I am a rate of change. I am a rate of change of velocity with respect to time. Yes.
Impulse. Impulse.
No. I continue. That makes me an acceleration. I am an acceleration due to an inverse square law. Yes. Go ahead.
Angular acceleration.
No. Did you ring? Acceleration due to an inverse square law force. I am universal as every object experiences me. Newton has something to do with me, so who am I? Yes, Forsen?
Acceleration due to gravity.
Yes. Clues, 3 points. 3 points. Next quantity. I am a vector quantity. I can change the state of motion or of rest of an object. I am closely related to force, but okay.
Impulse. Impulse.
No. I continue. I am closely related to force, but I am not force. My net value equals rate of change of angular momentum. Yes, Faisal.
Top.
You're right. Household chemical. I am a salt. I am a strong oxidizing agent. I am formed from the reaction of chlorine with sodium hydroxide. Yes, Peter.
We have sodium chloride.
No. The two of you. I am often simply referred to as bleach. Yes.
Sodium hypochlorite. Sodium hypochlorite. Sodium hypochlorite.